Aaron Barclage, metallurgical engineer with Schaefer Engineering. An alloy is simply a metallic material that's a mixture of two or more elements. Most of the metals you use every day are alloys of some type. Plain carbon steel or mild steel is an alloy of carbon, iron, and manganese. Brass is an alloy of copper and zinc. In the context of fire investigation, the term alloying is used when a low melting point metal, such as aluminum or zinc, comes in contact with another metal, such as copper. The resultant alloy that forms can have different properties than either of the two original metals. NFPA 921 discusses this phenomenon in the electricity and fire section. One common place where you might see this on a fire scene is when you're examining the remnants of an armored cable, such as BX cable. So here you have the copper conductors covered by their insulation, as well as the armor, which in this case is made out of aluminum. So if this piece is involved in a fire, the lower melting point aluminum can melt. That molten aluminum will drip onto the copper wire, and a new alloy can form. And in the case of copper and aluminum, this new alloy actually has a melting point that's lower than either the aluminum or the copper. What you can see on the scene is it will appear that the copper wire has melted, even though the fire may not have reached the temperature that's the melting point of copper. Let's see if we can recreate this phenomenon in a laboratory environment. Okay, as you can see, we've got our aluminum melted in our crucible here. We're just going to add one more little chunk to make sure we have a good sized bath for our experiment. Okay, so we have a nice pool of molten aluminum, and on top what you're seeing is slag. Aluminum readily oxidizes, and so that's pretty common with aluminum. So we'll kind of punch through it to get down to the molten metal. So while we're waiting for that to fully dissolve, I want to show you the copper conductors that we're going to use for our experiment. I've got two pieces of copper wire. It's about 12 gauge, I believe, and they are 5 1/4 inch in length. More importantly, they're the same length. So what I'm going to do is I'm going to hold one conductor in the flame. I'm going to put the other conductor down in the molten metal. The idea being that the one down in the molten metal will form a lower melting point alloy and will be melted into the bath. So let's see what happens. Okay, so as you can see, the copper in the flame is getting very hot. We're just using a mat gauge torch, and it should not melt the copper. But the idea being that the copper conductor in the flame is at roughly the same temperature as what we've got going on in the bath. You can see as I pull away the oxide or the slag that's formed, you can see the molten aluminum underneath. Okay, so we'll take our two conductors out. So let's see where we're at. This is the conductor that was in the flame only. This conductor was in the molten aluminum. Obviously, you can tell from the slag and aluminum that's still attached to it. But more importantly, we've lost about an inch of length off of this conductor, showing that it was alloyed, and we melted the copper aluminum alloy at a lower temperature than the pure copper. So we've shown that it can occur, but why does it occur? For that, we'll have to refer to an aluminum copper phase diagram. So what I've drawn behind us is a portion of the aluminum copper phase diagram. Think of the phase diagram as a map that shows the phases present for an alloy system at various temperatures. X-axis is the weight percent of copper and aluminum. Y-axis is the temperature in degrees Fahrenheit. So some key features here. When we have pure aluminum, the melting point is 1,220 degrees Fahrenheit. When we have pure copper, melting point is 1,985 degrees Fahrenheit. And what's very interesting about this phase diagram, if you notice this point here that's labeled eutectic at 33% copper in aluminum, that's our lowest melting point area. And that melting point is 1,018 degrees Fahrenheit. So if you ever hear anybody on a fire scene talk about eutectic melting, this is what they're referring to. Same thing as alloying. So what's happening when we put that copper wire into the molten aluminum, we're forming this composition, and this is the first composition to melt will be once we get about 33% of copper in aluminum. And that's going to melt at a lower melting point than either the pure aluminum or the copper. So now we've shown how alloying works in a laboratory experiment. We talked about why it works using the binary phase diagram. I'm Aaron Barklage. Thanks for watching.